Okay, we're at 2 minutes past the hour, so I think we are ready to start. So first of all, a very warm welcome to everybody who has joined the session this morning and this afternoon. This is the 2020 Excellence in Breeding Platform annual meeting. It is a virtual meeting this year because of the pandemic, but we're very grateful that so many of you have been able to join the session. My name is Bish Das. I'm with the Excellence in Breeding Platform. I work as the NAS coordinator based in Nairobi, and I will be the host and the moderator for the session this morning and tomorrow at the same time. So this is the Africa and Asia session. We do have a parallel session for West Africa and the Americas that will take place 11 hours from now. And for anyone who is interested, you're more than welcome to join that session too. So before we officially get into the meeting, we'd just like to introduce you briefly to Hopin. It's a new platform for so many of us. So we'll just go through a few of the tips to get you familiar with the platform and help you to navigate around it. But before we do that, for any of you who are interested to tweet, you're more than welcome to do so. Please use the hashtag EiB VM. So a quick tour of Hopin. On the left-hand side of your screen, you will see a number of icons. Please don't press any of them now. Just stay on this session for now. The first icon is Sessions. And that's where you will need to click to enter into the breakout groups later on in our meeting today. The icon below that is for networking. We will use that at the end of the meeting when we will have a networking session where participants will be paired one-on-one with each other to have a brief interaction. But again, please don't press that now. And the last icon is an expo icon, is an expo booth, sorry, where you will be able to see recordings of all the sessions, including some of the sessions that you were not able to visit. And that will remain live on this web page for the next 72 hours. So as we have the presentations, if you do have a question, you can ask it in the chat. So if you look on the top right-hand side of your screen, there is an option for chat. If you press in chat, there are three options that come up: event, session, and direct messages. Please use the session option. The session is where we currently are, so please click on session and then ask your question in the chat. If you would like to direct message somebody who's in this session, you can do that too. If you'd like to ask your question by video, you're more than welcome to do so. Please ask to share your audio and video. There's a little blue box again on the top right-hand corner of your screen. Once you click on that, the moderators will allow you to enter and ask your question to the presenters. So we're looking forward to a very open and frank discussion. Please do realize that all the sessions are being recorded and will be available on the Expo booth. If you're having trouble with Hopin, please don't panic. Usually if you refresh your browser, if you're using Chrome and just refresh the link, it should fix the problem. If that doesn't work, please exit and re-enter the session, and that should help in most cases. If you're using any other software that is using media such as Zoom or Skype, please close those now. And if you're still having problem, then please go to the Hopin event page, and there is an email and Skype contact for Sam Store, who will be able to help you directly. So we do hope it's a seamless session, but it is a new software that we're using for the first time, so there might be a few teething problems here and there. So in terms of the agenda, you've joined the Africa and Asia session. We will run for about 2.5 hours today, so it's not a very long meeting. We have the same tomorrow, and then we have a 1-hour global session on day 3. So today we'll kick off soon with the official welcome from Michael Quinn, the Director of Excellence in Breeding. We'll then share a story of excellence from one of our partners. Michael will then give an update on EIB and the current mandate, and then we will have a breakout session towards the end of the session today. So just to make sure we're all pretty familiar with Hopin and how everything works, I would just like to ask everyone to go through a quick poll, if we could. So if everyone could please click on poll. So if you look on your top right-hand side, see various options. There's chat, polls, and people. So if you click on polls and answer the first question. So the first question is, do you easily get distracted in virtual meetings? Okay, so we see quite a few people already voting, and many people are saying they do get distracted sometimes, but many people are remaining 100% focused, which is very admirable. So I'd like to ask you now to answer the second question. So just below that first question, there's a second question. What is your relationship with EIB? Okay, fantastic. So we've got a lot of CGIAR participants at the moment, and also some people from the private sector, interestingly enough. Okay, thanks very much. I think we are getting familiar with the system. Please bear with us as we go through this over the next couple of days. So with that, I think we can officially begin our meeting. So it's my pleasure really to introduce Michael Quinn, the director of the CGIAR Excellence in Breeding program, to share some opening remarks and officially open the meeting. So with that, Michael, it's over to you.
Can you hear me, Bish?
I can hear you loud and clearly, Michael.
All right, great. I will share my screen. Can you see my screen?
We can.
Perfect. Okay, thank you. Well, this is just a very quick 5-minute welcome and introduction. So welcome everybody to this meeting. Thanks very much, Bish, for kicking us off. And thank you everyone who's joined for giving us your time. This is difficult times at the moment, as you all know, and so to have your time right now is really appreciated. So when I look at if we look at the goals of this meeting for that are on the website, it starts off with strengthening EIB understanding, momentum, and partnerships, and part of that is understanding excellence in breeding as well, and really for us to explain that our goal is to support better breeding, better CG and NAS breeding, and there's a number of ways in which we do that. We provide tools and services and know-how, but we also are in our role of a cross-centre platform where we're driving for impact. So we're wanting to actively partner with the breeding teams, with the breeding leads to drive changes and to support you to implement changes, but to really set standards. To move forward in many of these ways, we need to move to standardized approaches, and so working with you on what those will be, and then laying those standard practices down, and then communicating with you what they will be, and working with you to get them implemented, and setting that direction, so that we are in a cross-crop sense. We're all headed in the same direction, and they're the roles of excellence in breeding. And so just wanted to start off with that. The next point on for our goals is that the stakeholders are updated on EIB strategy, priorities, accomplishments, challenges, and an opportunity for you to give feedback to excellence in breeding. That centres and NAS have CG centres and NAS have a stronger common vision for breeding modernisation in the future for CGIAR. And so this is really about sharing excellence, and that's the theme of this virtual meeting, and the objective is to share excellence with you. So firstly, in our role of setting direction, like I mentioned, to share excellence in terms of the principles and concepts of excellent breeding, much of which have been co-developed with many of you that are on the call, many of the excellent CG and NAS scientists that we have. But also going beyond the principles and concepts, in some cases even to present what could be described as a paradigm shift, which in the way that we think about how we go about our breeding. And these examples are particularly exciting because these are the areas where the impact through breeding can really be transformed. In that sense, we're really looking to build upon what we our previous engagements with you over the previous 12 months, and even all the way back to 12 months ago at our face-to-face annual meeting in Amsterdam, which some of you will have been at. At that meeting, we really focused on the DDGRs and some breeding leads to present the vision of CG breeding, and to really gain strong sponsorship for that modernisation initiative, which we're all a part of. And that was really very successful. All of the DDGRs really bought into that. The DGs also, we had a separate session with them in Rome last year also, and the DGs are really bought in and are giving this full sponsorship, as are the funders, and all the way to the system management board. So we've got strong sponsorship for this, and we're wanting to build upon that vision that was shared, to now take it to the next level and really show, okay, that's the vision that was presented, but how do we actually implement these? How do we get there? How do we get to that end state, that end goal that was presented? And so that's what we want to take some opportunity today to do, to progress that conversation, which we've been having with you over the last 12 months. And I mean, when I started off by saying that Excellence in Breeding is here to work with you to increase the impact of breeding, to increase rate of genetic gain, to increase the variety turnover in farmers' fields, to reduce the average age of varieties in farmers' fields. And to do that requires implementing change and implementing new and better ways of doing things, and that can be challenging. And so we're wanting to address that up front and point out that we can't do this without you, that we at Excellence in Breeding can only be successful if you are successful, if you are successfully implementing these changes and seeing better results from your breeding. So we see ourselves as being, we'd like you to see us as your partner in this process, and we can't do this without you. So with that, finally, when it comes to sharing excellence, it's not just in the principles and concepts, but also by showing what's being actually applied already on the ground and in CG and NAS programs. Ideally, we'd like to be able to showcase all the fantastic things that are happening, but we won't have time for that. But we do want to take some snippets and show you some of that. So the next session with Ronnie, he'll show what's happening in the banana program. And finally, this will be an opportunity to meet and network with global breeding experts, which we've got attending, some of which are in the CG, some are from outside, and some from Excellence in Breeding. So with that, thank you very much. And I'd like to turn it over to, I guess, Bish to introduce our next speaker to get started with that, for that objective of sharing excellence in at least one program. Thanks very much, Bish.
Okay, thanks very much, Michael, for those words of welcome. And as Michael said, we're really excited now to welcome Professor Ronnie Swennen to share a story of excellence. Ronnie works with IITA as a principal scientist He's worked with bananas for close to 40 years now, a world expert in the field. He's published over 250 articles and has received numerous awards, including honorary chieftainship in Nigeria in recognition for his work on plantain research and improvement. So with that, Ronnie, I'd like to ask you to share your slide and kick us off. Over to you, Ronnie.
Good morning, Bish. Good morning, Michael. Good morning, all the participants of the meeting. Bish, can you confirm you can see the my presentation?
We can see you, Ronnie, and we can hear you clearly. We can't see your presentation yet.
Can you see it now?
No, not yet. Is it open on Google Slides on a separate tab?
Yeah. It is. It is.
So
Sam, maybe can somebody take over? Then we move on. Sam.
Sure, we can do that. Sam, could you share Ronnie's slides?
Sure, I'm about to share the slides now. In just 1 second. So Ronnie, just let me know when you want me to advance.
Please, yeah, I will do. Okay. Is it? Can we start, Sam?
It should be displaying. Can you not see it?
I can see it. Okay. So good afternoon, good evening. While I'm just digesting my breakfast in Belgium, I would like to share the experience of the EiB banana team in breeding matoke bananas, which are in fact the highland cooking bananas of Eastern Africa. My talk has basically 4 messages. First of all, banana breeding is possible. The second message is that we are soon going to release new hybrids in Tanzania, and soon means either this year or next year. Number 3, it's because of the close collaboration between the national programs in Uganda and Tanzania and EiB and another range of partners that we were able to do that. And lastly, the point is that I think we have now a breeding system. It means that if people drop out, the breeding will continue. Next slide, please. So the yield of the highland cooking bananas of Eastern Africa, grown above 1,000 meters above sea level, is very low. You see that the yield is about 5 to 30 tons per hectare, and we can achieve 70 tons if we start changing the way we are farming and the use of varieties. Next slide, please. But the low yields are caused by pests and diseases which are invade the farms, but also which are being transmitted through the planting material. So on the left side, let me show you the underground problems. So the nematode and the weevil, the 2 pictures on the left side. Basically, in essence, the yield is not less, simply the plants fall over. So it's a problem of uprooting. In the middle, we have the fungal disease Black Sigatoka destroying the leaves. So you get low yields, but also a reduced shelf life. And then on the right side, you see Fusarium, the yellowing. You all are hearing about Panama race 4 destroying the export rate. In Eastern Africa, it's Fusarium race 1, which is basically a problem. It's not a problem for matoke, but we have to make sure that our hybrids remain resistant. And then on the far right, we have a disease called resulting in bacterial wilt, and therefore plants are dying off. We have found for all those pests and diseases sources of resistance, including bacterial wilt, against all common belief. Next slide, please. So, next, please, Sam. So we are breeding for resistance, and basically we have a tremendous challenge. About 6,000 to 7,000 years ago, mankind has selected among the edible banana, among the seed producing bananas, sterile bananas. They're sterile, and we breeders have to turn this into a fertile banana, and in the end deliver again a sterile banana. Then we have a polyploid. Well, most bananas which are cultivated are triploids, but in the course of the breeding process, we have to bring in diploids, we have to bring in tetraploids, and we have to combine them. So it's quite a challenge to bring all those different ploid levels together. And then next is the perennial. The perennial, you see that, no, please don't go next slide. So we have another challenge, perennial, good for farmers, because once you plant a banana, please go back to the previous slide, then thank you. Once it's in on the farm, you have it for a generation. But for a breeder means basically that we have the data coming in very slowly, and from seed to seed, it's about 2 to 3 years. But the mission is very important. 3.3 million people, households depend on the matoke bananas. More than 10% of the world production is in Eastern Africa. It's even more than the global export rate. And people consume up to ½ kilogram per person per day. And if you put it in dollars, it's about $4.3 billion, which is involved. Yeah, next slide. Next, please. So, what are we going to deliver, or what we have delivered? So we have published last week our paper on heterosis in banana, and this is our champion, that after 17 years of breeding, we have a 249% yield increase. And so we have tested them in 5 sites in Uganda and Tanzania for 2 to 3 cycles. And now we want to make them available. Now, how do we make them available? Next. Well, we can do that through the classical distribution of planting material. So basically underground branches. But if you do that, we can transmit again all the pests and diseases. And that's why next we are in fact going to distribute it through multiplication centers, which are either doing micropropagation, on the right side you see the picture, or through tissue culture work. So this is in fact what we are doing, and that's part of another project which I'm not leading. It's led by MEDA. It's a Gates Funded project, and they have done the landscaping in Uganda and Tanzania and found 25 possible partners, and they're going to gradually narrow it down to 6 to 7 for scaling up the material. Yeah, next slide. So the process. Well, you see the sterile banana, among all the matoke varieties we've tested, 15 out of 28 produce seeds. And when we say seeds, hooray, less than 1 seed per bunch. But the potential is 30,000 seeds if you would count the number of ovules. So we only get 1 seed. And that will not germinate unless we do extract the embryo next. So that which is called basically embryo germination. So we extract the embryo out of the seeds, put it in the lab, and after 2 months of growth, we have it germinating. So this is quite a challenge. But if we are going to move from the triploid level to the tetraploid level, the game is changing. Then instead of having 1 seed per bunch, we can get more than 1,000 seeds per bunch. Then the pace is accelerating. And we bring in our diploids, then we have about 44 seeds per bunch. And also, embryo germination is much higher. It can go sometimes up to 22%. So basically, the starting point, the land race, is our major bottleneck. And the second one, of course, is the time. Yeah, next. Well, let me go through the breeding process, and I'm going to show you basically a story of 17 years. Next. So we are going to use, on the far left side, yeah, next, the matoke landrace, which is a triploid, and we cross it with a diploid, 2x. And the combination of the 3x with the 2x results in a tetraploid, the 4x. So that's our F1. And then in the next step, and this is already a resistant material, not always for everything, and then we have to move back to triploid level. How do we do that? Well, we're going to cross again the tetraploid with a diploid, and we end up with the triploid, which is sterile. And you see, if you look at the picture, we use twice 2x. The first one is a non-improved diploid. The second one is an improved diploid. That's why we also have a diploid breeding program to accelerate the pace of getting high yields. Yeah. Next slide. So since in banana we are able to pollinate every single day, because the plant is flowering anytime in the year, and we are extracting seeds anytime, we have barcoded everything. So all our plants in the field are barcoded, our bunches are barcoded, our seeds are barcoded. The tissue culture work, basically, I would say, as a kind of a joke, everything is barcoded except our stuff. It means we're able to follow up what's going on, and it's also not, so we make less mistakes, but in the end, it's easy also to, I would say, for our reporting. Next. Now, yeah, next. So to get there, we have been able to access germplasm, improve germplasm from our Brazilian partners. We are getting material from Australia. We get material from India. The plan is to get material from Malaysia. And as I said already, multi-location evaluations going on. And of course, very important, we have done the sensory evaluation that we say what is acceptable for our consumers. Yeah, next one. So now to conclude, not to conclude the presentation, but basically to conclude this slide, is basically banana breeding has become realistic. Look at the numbers. In 5 years, more than 230,000 seeds, more than 160,000 embryos, more than 10,000 matoke hybrids. And in the end, we have selected 231. That's all what's happening in the past 5 years, thanks to the support of the Gates Foundation. Next slide. Next one, please. So let me introduce a few of the all the partners. The hardcore, I would say, the focus is Eastern Africa. So we're working with the Uganda National Program, NARO, the Tanzania program, TARI, and based at Nelson Mandela in Arusha in Tanzania. And together with the ITA, we have basically the platform for the breeding work. But then we need to screen for resistance to Fusarium. And that's done, for example, in South Africa at the University of Stellenbosch. But now that we are starting with high numbers, thousands of numbers, we have brought in a new partner, which is Wageningen University, which will deal with a large-scale screening for Fusarium. Now, everything is barcoded. That means also we have our field books, and everything goes straight to our MUSA base, our database. And that was developed by Boyce Thompson on the left side in the United States. And the germplasm came from Brazil, Embrapa. It came on the right, let's say, from India, the yellow part, and also from Australia. And now we are developing molecular tools with our Australian partners, with our Malaysian partners, with Kijin, a company. And we are now looking for breeding values. And that's what we're doing with the company in the United States. Yeah, next slide. Next slide, please. So what are we learning from this one? Well, 3 important things. We have to focus on, yeah, next one, on improving the multiplication sites. And this is not about the technology. It's not about tissue culture. It's not about micropropagation. It's about the business attitudes. A lot of failures in the past because there's not a business mentality. And the quality control. No varietal mixtures should be allowed anymore. Virus indexing is needed. Yeah, next slide. And then rapid selection. It means basically, let's start using our tools. And first of all, quality has to be evaluated first and not last, like we did in the past. And then our molecular tools we have, let's use them. We keep on developing and developing. It's time to start using it when we select. And next slide. So breeding efficiency has to improve. And that means that we have to work on the breeding values, which I mentioned, but also we have now developed camera-based systems for our banana flowering. And what do we see? We pollinate during the day and bananas are flowering at night. So we have to rethink how we are optimizing our pollination system and get more seeds. Yeah, next slide. So we've reorganized our system from phase 1 to phase 2. And basically what does it mean? That in phase 2, pathology is not anymore independent. Pathology is in the service of the breeders. The end users, it's in the service of the breeders. So it's all under the breeding leaders now. And yeah, next slide. And now we have also added next to the pre-breeding and data management seed delivery systems. Yeah, next slide. So coming to the end, this is the last slide. It's a complicated slide and I will not guide you through all this. But the point I want to make, first of all, we're involving a lot of polyploids, different steps. And yeah, next slide. And it means now we have a quality check. So it means that we are fingerprinting our material during the process to avoid any mistakes. Then we have the barcoding system. that we know what's going on, and also that our field book tells us what to measure at what stage. Next. And then you see that our bioassays are now in place, except one, and it's time to use them now for screening and stop optimizing it. It's time to really start roguing. Next. And then, next slide. And then to conclude, we see we have a lot of molecular tools. We have also some maps coming in, and it's time to, in fact, narrow down our work on the different pests and diseases. It's better to have a few good tools than saying many will be developed in the future. So with that one, I would like to conclude. And by concluding, I want to say the following. First of all, thanks to my team, which has been working for so many years on this work. Secondly, I would like to thank the partners, especially our national programs, but also the ones in the other continents. And lastly, I would like to say also thanks to Excellence in Breeding, because since Excellence in Breeding is around and gives so much advice, I feel that I'm not anymore alone with our team. We are basically coached by them, and I'm very grateful, and I'm sure our pace will accelerate in the future. Thank you very much.
Okay, thanks so much, Ronnie, for that inspiring presentation, and thanks for all the work that you do on such a challenging crop. What I didn't mention, Ronnie, before your presentation was we did receive close to 30 submissions for stories of excellence, and 4 were selected to be presented at plenary based on online voting, and your story was one of them. So as I'm looking down, I see one question in the chat, and I think we do have only time for one question at this stage, and that comes from Aparna. And she's pointed out that you've reported a very wide yield range from 5 to 30 tons per hectare, and she's curious about what causes such a wide variation in yield in bananas.
Well, in a sense, we have and I want to use the case of Uganda, but I can extrapolate to other countries. You have farmers which are producing bananas for self-sufficiency. And these are the farmers which are growing bananas with trees, with coffee, with sweet potato, with maize, a whole range. That means basically, first reason for low yield is the low density. The second thing is also because it's self-sufficient, that means not much cash is involved, and therefore not much manure is being applied, and not much mulch is being applied, and they never apply fertilizer. And the last point is basically planting material goes from farm to farm, so it's always contaminated. And then you have the commercial farms, which are basically eliminating the coffee and the maize and all the other crops, and gradually moving to monocultures. It's still a mixture of varieties. And these people, they have big cattle ranges, so they're using manure and bring it to the farms. Still, they use basically their own planting material, no tissue culture material, no fertilizer. But these basically are the two extremes of why we have 5 to 30 tons per hectare.
Okay, thanks a lot, Ronnie. And I see another brief question which I think we can attempt. So Suresh is asking, is banana seed free from viruses?
It depends where you are in the world, and depends what variety. If we accelerate to the genus Musa, to the Musa, anything which has the B genome as an integrated form of a virus, which is called banana streak virus. It's integrated in the genome, so it's there and only expresses when there is a stress. While the other ones, the other viruses, there are another 4, are brought in by insects. So in Eastern Africa, at this very moment, we have in the surrounding areas of Tanzania and Uganda, so in the Congo, we have in Malawi, we have bunchy top. It's a killer. You have bunchy top, it's over, nothing but grow. So that's why we also are preparing our roads for this one. The other is Combo mosaic virus, which is transmitted through wheat. So wheat control is extremely important. So there are some virus issues, and there are DNA viruses and RNA viruses, depending on the case.
Okay, thank you very much, Ronnie, and thank you for the questions from Aparna and Suresh, and thanks for that very entertaining presentation. So with that, we'll move on to our next session, and we're back to Michael Quinn, and Michael's going to give an update on EIB's mandate and vision going forward. So over to you, Michael.
Great, thanks, Bish. Can you hear me and see my presentation?
We can see you, and we can see your presentation too.
Okay, perfect. Thank you. Thanks very much, Ronnie. I'll get straight into this. So I would like to take this opportunity to, I guess, to tell a bit of a story, to take a look back and look at where we've come from, to have a look at where we are right now, and then to spend most of this presentation looking forward and looking at the next steps, with a particular emphasis on the 3 areas, responding to the 6 requests that have been laid down to us from the Crops and Hunger funders, Crops and Hunger investments, and updating improvement plans. So I'll get into that at the end. So leading up to this point, where have we come from? We've come from a realisation that the current rates of production increases will not meet projected demand. If I just take a look at this slide here, using maize and wheat as an example, the annualised production increases are going to need to be greater than 1.7% to prevent price rises. And that's using them as an example, but it's not just the staples. The root, tuber and banana crops and legume crops also play a critical role, particularly for poverty alleviation. And that was one of the main findings coming out of the 2018 IFPRI analysis by EiB et al. That has been used to drive prioritisation for CG breeding. Just to look at a little bit more closely, if you look at this is the, if you can see my pointer, I'm not sure if you can, I probably need to, if you extrapolate this, then this will be our continued, this is based on historic rate of production increase, then there's a gap between what is needed and that projected amount. And this is before taking into account downward pressure from climate change, reduced water availability, diseases, etc., and same for other crops. So that's where we're at. The production increases we need to increase production, and also we've been, I mean, the current rates of genetic gain that are being delivered are below what is expected of us, and so and this has come out of the BPAT reviews that they've been through, and the overwhelming message from those reviews is that we really do have a strong opportunity to increase rates of genetic gain being delivered to farmers, and so we need to take that opportunity. There are opportunities in terms of execution of the fundamentals, and there's including just better quality data, plot and ship, this sort of thing, but also opportunities to implement new technologies, approaches and methods. So it is an exciting time, and funders are mandating higher rates of genetic gain and faster rates of variety turnover being delivered to farmers in the form of farmer preferred varieties. And these funders are showing great interest in supporting CG and national programs to deliver against this. So still looking back, in April of this year, the funders laid down these 6 requests, and I won't go into them here because I'm going to go into each one of them in detail a little later in the presentation. But we've got 6 explicit requests, and these come collectively from the 5 funders that fund at least 75% of CG breeding. From the Gates Foundation, USAID, UK government, Germany and Australia. Okay, so if we bring ourselves to where we are now then. So right now, all of us, we're in the process of a vital and crucial initiative to modernise CG and NAS breeding, a modernisation drive, if you like. And if you were to ask, what does it mean to modernise? Really, it's about, the vision for CG breeding, which was shared last November in Amsterdam, is to have CG NAS breeding networks generating rates of genetic gain that are at least 1.5% per annum in the form of farmer preferred varieties. So this is not just about yield, but this is once end use quality and disease requirements, etc., are also accounted for, and that the average area weighted age of varieties in farm fields is brought down to below 10 years. And a detailed vision for CG breeding was was presented at that meeting and can be found at that link. And this presentation can be shared, so you can have all these details. So when we're talking about modernisation, or we're talking about increasing the rate of genetic gain, what we're talking about really is implementation of change. And because we can't move to improve methods, we can't incorporate new tools or technologies without changing the breeding process or breeding program. And so it's about implementation of change, and change can be really, really difficult. And it's not about looking back and saying that any particular one thing or another is being done wrong. It's about saying we've got an opportunity in front of us, so how can we take that opportunity and deliver higher rates of genetic gain? To be successful, a change initiative requires these critical success factors, which I'll point to in just a minute, but at the bottom there, it also requires the need for clear goals to be set and a plan for achieving these goals developed. And this is really the central idea around the improvement plan, which many of you have been working on since I think probably 2 years ago now, and there was a lot of work on it up until halfway through last year, and then probably not so much since then. So I'll talk a little more about that as well. So to just quickly back to these success factors, there's been quite a lot of thought put into how to make sure that we have these success factors. So the first one is accountability. If we're wanting to drive change, then there have to be people who are accountable for that change. And so a breeding lead from each centre has been appointed by their respective DGs, such that each CG breeding centre has a breeding lead which has been appointed and is accountable for developing plans and for implementing against those plans. And Excellence in Breeding has been mandated to monitor progress and to provide support. And this is the central theme behind the Crops to End Hunger accountability and implementation mechanism, whereby the funders, Excellence in Breeding, and these 9 breeding leads get together on a monthly basis to review progress and to look at how to move forward against the 6 requests, which I'll get into shortly. The next point there is that for success, it's necessary to have sponsorship of the modernisation initiative, and that was the focus of the Amsterdam meeting last November, and that was very successful. And out of that, I mean, we've got full endorsement, sponsorship of DGs, DDGRs, breeding leads, System Management Office, System Management Board, the System Council. They all approved critical Crops to End Hunger initiatives, which are totally aligned with this modernisation initiative. Technical support comes from Excellence in Breeding, and like I mentioned earlier, we're really about driving impact, and so we also go beyond providing the technical support and providing that direction and partnering with you with a mutual expectation. On our side, there's the expectation that we provide that support, and on the breeding team's side, there's the expectation that these changes are implemented. And financial support is being provided through the Crops to End Hunger funding, which is being managed by Excellence in Breeding, which is there that is not for operational support, but for supporting the modernisation initiative specifically. So for those one-off investments that lead to higher rates of genetic gain per unit of time and per dollar invested. And lastly, support for non-technical aspects to drive change, I guess the more human side. And it would be silly of us to not acknowledge that this is important. And so we are using change management professionals to partner with breeding leads through this process, so that to support you to implement your own ambitions for change. Okay, so looking forward now then, and this is where the bulk of my presentation will be, particularly in these 3 areas, and starting with the implementation of change and response to those 6 funders' requests. And so in our role of setting direction, then it's important for Excellence in Breeding to give a little bit of a description as to what's under the hood in terms of each of these requests and what it means to respond to them. And a lot of this has been developed, like I said earlier, in in partnership with many of you. So the first request is the need to develop a pipeline investment case. And the first step here, and Peter Coldrake in his breakout session will talk more about this, the first step here is to define the market segments that you're breeding for. Now, of course, market segments are data-driven, but they're man-made. At some point, a decision needs to be made as to where the boundaries will be drawn around a market segment, but they are data-driven. And once those have been defined, then breeding pipelines need to be mapped to market segments so that it's clear what any particular breeding pipeline is breeding for. Once this is in place, then it's possible to develop the pipeline investment case. Now, this is likely to be the unit of investment going forward. And firstly, that's why it's so important to get this done. But it's also an important way, it's a useful way to gain focus, because with this approach, it's rather than taking a trait-based approach or a general agroecological zone approach, in this way, it's much more possible to be more targeted in terms of replacing varieties and having the end in mind in that sense, and having a greater level of focus in terms of the breeding objectives and the individual breeding pipelines, and even to the point of understanding how many breeding pipelines are actually required for any particular crop by region combination. So once the pipeline investment case is developed, those sub-points, it's important to cost these pipelines so that they can be presented as part of the investment case, because for the purpose of portfolio management from the funder's perspective, that is important. And then also, so that's more of a top-down approach, but from a bottom-up approach in terms of understanding the costs of individual operations for every plot, for every hybridization, for every quality assay, that's also necessary for the purpose of optimizing breeding schemes. And then finally, once the market segments are defined and the pipelines are mapped, then having a product profile for each of these market segments. Now, this is for a bit of a different purpose. The product profile is a tool for the breeding team to use in terms to guide selection decisions and to ensure that breeding objectives and promotion decisions and parental selection decisions are entirely aligned with the needs of the market segment. So that's the first one. The second request is around incentivization, and this is really all about putting the two high-level KPIs for crop stand hunger, which are a rated genetic gain of greater than 1.5% per annum and faster turnover of varieties, and so the average age of varieties is less than 10 years, putting those two metrics front and center, so that breeding teams and individual scientists' performance should be assessed on the basis of contribution to these metrics, to genetic gain and variety turnover, and to NAS support. So there should be an annual health check of programs performed, and in that annual health check, then realised genetic gains must be calculated, and this needs to be done in a standardised way. And Excellence in Breeding is working hard right now to develop those methods, and Eduardo, I know, has done a lot of work in this area, and there's a new biometrics lead and module 5 lead, Young Hua. She's I mean, this is really a biometrics issue. She's working to have simplified methods for you to execute against in a standardized way, so that we can all be using the same methods. So realized genetic gains is one thing, but it's a lagging indicator, and what we really need in addition is a leading indicator. And for that, we also need predicted genetic gain to be calculated annually, and not just annually, but also every time the breeding scheme is redesigned, every time you make a plan to do something differently, whether it be drive down your cycle time or increase your accuracy in some way, then to repredict this is is what's needed. And to predict this really is about just plugging in the numbers for the components of the breeder's equation, plugging in what is your breeding cycle time, your selection accuracy, intensity, and your the genetic diversity, but also the mean of the parents that are being used. How elite are the parents? Because that's one of the fastest ways to increase genetic gain is to put greater selection pressure on the parents being used and exclusively use only elite parents. The next request here is around an effective delivery mechanism. So working with the seed sector to ensure effective pipeline of delivery from breeding program to farmer. And so in many cases, this is outside of the control of the CG program, but this is about having good partnerships and ensuring that that pipeline exists and doing what's necessary to ensure that the outputs of the breeding program are getting to the farmers in good quality. So ensuring that there's a high quality handover of germplasm, for example. So it's about the quality of the seed and the stock and the purity being delivered, but also backed up by sufficient performance data under relevant farmer growing conditions, so that that seed sector can invest with confidence, knowing that that data is underpinning that decision. The next one is around having implementing a redesign process for the breeding program, the breeding scheme, and optimizing that breeding scheme for the purpose of increasing the rate of genetic gain. And the breeder's equation is off there to the left, and that's really what this is about, is optimizing that. And of course, you can't just maximize every of those components, because there are trade-offs and budgets are not unlimited. So within any given budget, how do you make those trade-offs decisions? And since cycle time is the denominator there, then that is one of the fastest ways to increase genetic gain, along with ensuring that the parental material is strictly highly elite and only using highly elite lines. And that's normally done by recycling quickly and not bringing in new germplasm and having a mostly closed gene pool. So shortening the breeding cycle time, but one of the key ways to do that, to shorten cycle time, is to reallocate resources to invest in the accuracy of trials, particularly in early generations. A more traditional breeding approach is to use stage 1 and maybe even sometimes stage 2 trials or first year trialing to just get rid of the poor performance. Whereas if that is reconceptualized and the purpose of that very first stage of testing is to identify a parent as quickly as possible, then that requires redesign of the program and rethinking how you think of that stage and how you think about the breeding pipeline. So multi-location trials in early generations will be necessary that are highly predictive of the TPE across years. And to get that across years, predictive ability is often necessary to have managed environments. To have a population improvement focus rather than product development, and I'm sure Eduardo is going to go into this in more detail. Like I said, exclusively elite by elite crossing, and separation of variety or parent development from the trait development process, from population improvement. So that's not to say that parent development, trait integration or trait development is not important. It's critically important, but it's about saying that we don't want to just lump all of these approaches into the same pipeline. We want to have that parent development servicing the population improvement pipeline. Okay, so the next point is to really have commitment to shared services. I'm not sure if something's gone wrong in my presentation. There's a bunch of examples that are supposed to come up on the right-hand side there. And for this, really, partnership is key. That's the first point I wanted to make. And the concept here is that we establish and use shared services instead of investing in duplicated internal capacity. And one of our earliest examples of this is in genotyping, which started with Vicrostat and with the high throughput genotyping project, the Ingwa Ing has been leading since the start, and is still as our module 3 as our genotyping lead in excellence in breeding is still leading, where it's important to commit to this, and it's often for the benefit of CG breeding as a whole. So if, for example, there is I don't know, $1.5 million worth of genotyping happening, and if we can outsource and get that done for $1 million and save $500,000, then that's what we should do. Even if for one particular crop in one particular circumstance, it may be marginally more expensive. This is what we need to do, and we need to commit to it. It's about ensuring increased capacity can benefit multiple crops and centres. And we're looking to develop centralised business units, whether they exist, particularly for when we're investing in 3 crops in hunger in additional capacity, internal capacity. We're wanting to do that in a way that can benefit multiple crops and centres, and there's more on that coming up. And we're wanting a flexible region-focused approach that will likely be used. So for we're wanting to do that, for example, in biometrics, where we're wanting to put in, we're wanting to add to the existing capacity in a way that ensures that within any particular region they have sufficient biometrics service, and that this is not necessarily for any one particular crop or centre that it's shared. Oh, okay, so sorry, there's the examples. I didn't know how to use my computer, sorry about that. So there's a range of examples where this can be applied. And lastly, for the last request, that NARS breeding networks and NARS capacity be really focused on in a way that hasn't necessarily been done by all crops in the past. So funders are looking to fund CG NARS networks rather than standalone CG breeding programs. This is how they're looking at the relationship. And so we must partner strongly with the national programs. We must work actively to build them up and to build up their strength and capacity. And eventually national programs should have an increased role for product identification and release. So extracting products from improved populations, which is the domain of the CG program. So for CG to focus on population improvement and on parent development. So they're the 6 funders' requests that have been laid down, and it's up to, like I mentioned before, the breeding leads to work with their teams to respond to this, and it's up to Excellence in Breeding to support you and to monitor progress. That's our role. And so the next area I want to talk about in terms of looking forward is the Excellence in Breeding managed crops and hunger investments, and I did start to talk a little bit about this under the shared services. With these investments, we're looking to take a centre agnostic 1CG approach, to take a hub and spoke model in each sub-region, and that is to identify a hub that can be really invested heavily into to get up to a really high standard, but also to acknowledge that there are trialling locations that could be thought of as spokes that also we need to invest in ensuring that high quality data comes from those smaller locations. And when we do this, we're wanting to invest in these hubs so that they are for the benefit of multiple crops within the region. To start with, we're wanting to take this approach with a focus on Africa and South Asia, and there'll be opportunities to develop centralised operations and services, including across centres, acting as business units. This is the vision that we're wanting to implement, or that we're planning to implement with this funding, and partnering with many of you to make this happen. And by establishing these centralised units as business units, this ensures the long-term sustainability, so that the flow of funding through the breeding operations budgets can keep it sustainable. And there'll be a focus on delivery of quality through specialisation and resulting in efficiencies. And again, I'll just reiterate that the partnerships will be critical to making this happen. And this is all for the purpose of some of those things that are in the green box off to the side: increasing heritability, multi-location trials, rapid generation advance, etc. Okay, so now the last point I wanted to make looking forward is the ongoing optimization and revision of improvement plans. So like I mentioned earlier, a lot of effort went into these, and I realized that it was tedious, and I realized it was a lot of hard work, and I appreciate that. But really, we need to have a plan, and these need to be continuously updated. And I guess in terms of trying to answer the question of how they're going to be used, well, those detailed plans are needed as a management tool for the breeding leads and centre level management to hold the breeding teams accountable, and to know who's responsible and accountable for what, and to map out exactly what's going to happen, and to be confident of in terms of the accountability function, just for everybody, all stakeholders, to be confident of successful implementation, to know that there is a plan there, a detailed plan for achieving these things. Having said that, it seems that many of these plans have sort of been put in the drawer and not necessarily updated since they were worked heavily on in the first half of last year, and that's a problem. And so I do wonder whether it's useful to begin with a higher level plan, focusing on just the objectives and the immediate outcomes as a suggested starting point. And in terms of how this could be used, and the reason for this is that can then be used to get started on the more detailed plan, but also as a communication tool for the Crops to End Hunger accountability implementation mechanism. It can be a tool to use for discussions between EiB and breeding leads, so that we can know, okay, this is the commitment that was made, and we can regularly check in and say, okay, where is this at, and how can we support you, and if things are getting off track, so we can quickly say, okay, well, who's the responsible, accountable people, what's required, we've got a plan here, how do we get it back on track? So for early diagnosis, for alignment, both internally and externally, so that, again, as a communication tool, all stakeholders are aware of what the ambitions are, what's happening in any particular centre, so that centre can be supported to implement against that plan. And finally, pardon me, for communicating to funders the specific commitments that are being made to respond to those 6 requests. So an example of a high level plan, this is a very ugly slide, and I apologise for this. There's a lot of detail there which I won't even go and look at, but that's the larger picture. If we zoom in on just one of these and look at those headings, what I'm suggesting is that on the left-hand side there, we'll get my pointer up, we've got objective. So here the objective is to have a health check. It's funder request number 2, that we need to be measuring realised genetic gains. Here's the actions, the immediate actions to make that happen, and description of the current state, and a commitment to how things will be after 3 years, and what are the indicators. So what are the things that will tell us that this would be done? So for anyone who wants to look at the details, here's an example of how of some objectives that could be used to respond to each of those requests. So this is my last slide now. So in summary, we are all part of a CG NARS breeding modernisation initiative. We're all in this together, and Excellence in Breeding is wanting to do everything we can to support your success, and because we're not successful unless you are. There are many components in place for success, as I went through earlier, and we each have a role in this initiative. Breeding leads are accountable for the plan and for the implementation. Breeding teams are responsible for the implementation, and Excellence in Breeding for providing support, the tools, the services, for providing the direction, for providing the standardised approaches for when they're required, and the cross-crop direction in terms of what good looks like in terms of breeding. And finally, that implementation is what this is about, and specifically referring to the development of a plan to respond to those 6 funders' requests, and that should be done by updating those improvement plans, and then of course execution against that plan. So with that, I've gone a little longer than I would have liked, so I apologise for that, and there is still time for questions. So thanks very much, Bish.
Okay, thanks very much, Michael, for that presentation. A lot of information there, a lot of useful information. So we'll open it up for questions now for the next 15 minutes or so. If anyone has a question to ask by video, please put in a request and Sam will put you through. In the meantime, I'll just go through the chat list. We've got a few questions that have come through on the chat. So the first question is from Chidozi. And Chidozi says, it might be important to have a common understanding of the relative meaning of annual health checks. So Michael, if you could elaborate a little bit more on that, what you mean by the annual health checks.
Yeah, I mean, in that example that I had, in the example of that very ugly slide, I mean, I just pointed out two. One is to calculate realized genetic gains, and the other is to calculate predicted genetic gains. But it could become broader than that. I mean, it could also be to look at the processes that are in place. But really, I mean, they're the two important indicators for genetic gain, at least. I think at Excellence in Breeding, we've still got work to do to develop indicators for those other funders' requests and to make them as quantitative as we possibly can. But it's a good question. The starting point is those two areas.
Okay, thanks a lot, Michael. I hope that answers your question, Chidozi. And again, please feel free to request video to ask your question directly if you'd like to do so. The next question we have is from Aparna, and she says, assessing performance on the what component can be done by the parameters explained in your incentivization slide. Any indicators defined for assessing the how component of performance?
I'm not sure I understand the question. She's asking for indicators of how well incentivization is being aligned.
I'm not quite sure myself that I understand the question. Aparna, would you like to join on video to ask your question directly? Maybe let's come back to that question in a bit. Oh, here we go. Here's Aparna, she's on. So Aparna,
can you hear me?
Yep.
Yeah, hi Michael, thanks for the very nice presentation. So my question is more on like, you said we have these parameters on what, like we will do the genetic gain assessment, but on the performance there is a how component, like how well it was done. People may have reached some place, but is there any way you will assess like how it was done, like partnerships were involved, or was it done in isolation, or stuff like that on assessing the way it was done? Is there any indicator to find?
For genetic gains?
For any of the components,
Oh.
or what that are there.
Yeah, look, I mean, this is going to be an ongoing issue, and how some of these things are measured is going to be an ongoing thing. It's something that I think we need to be putting more thought into, to be honest. Right now, we just need to understand what those indicators are and what are the standardized ways in which they will be measured. And I think then the next step is, okay, how do we look at, I guess, the details and the how, as you put it. So I think it's going to be an ongoing conversation, and it's going to be a more detailed conversation than I think we can probably have here.
Okay, thanks, Michael. And of course, it's a relatively short session today, so everybody please be reassured that there will be opportunities for follow-up in the future for a deeper dive. The next question comes from Phineas. So Phineas is asking, the EIB is bringing CGIAR and NARS together, but some NARS seem not to be following what is going on. What is your plan to make sure all NARS are on board?
Yeah, this is a good question. Maybe I'll throw it to you to finish. It's your area. I mean, really, our role here is to is to set the direction in terms of what good looks like for a CG NAS breeding network, and then to work together with CG programs and national programs to achieve that outcome in a way that works for them. Of course, I mean, some of these things we just want to get 80% of the way there, but then for any particular partnership, they have their own ways of making it happen. In terms of your specific question, I mean, I don't understand whether it's a case of NAS not understanding what that vision is, or if it's a case of the national programs, some national programs not really being interested. I mean, at the end of the day, I think that we need to work with them in a way that that achieves the high level outcome that we're looking for, which is faster variety turnover in farmers' fields. And in many times, it's the national program that is the final leg in that process. And so whatever works for them in that case is going to be how we're going to have to do it. Bish, do you have something to add to my answer?
Well, just to reiterate really what you said, I mean, from EIB perspective, we really do see the national programs owning those downstream components of the pipeline, release, on-farm trials, getting the varieties to farmers. So we see national programs playing a really critical role in the entire pipeline. I think it's a great question, Phineas. Scaling is something we're actively thinking about. Over the last couple of years, we've engaged deeply with a couple of pilot national programs in Kenya, Uganda, and Ghana. But I mean, if we just look at Africa, we've got about 50 countries. Each country might have 10 crop breeding programs. We're easily getting up to about 500 breeding programs. It's beyond anybody's capacity to reach all of them. So we are actively thinking of ways to scale. We will have a breakout session later today on the NAS engagement strategy, and you're very welcome to join that and share any ideas you might have or any guidance you may have for us. So that's what I would add to what Michael's just said. So I think we can move on to the next question. So we have another one from Chidozi, but before that, we will ask Ronnie so that we have a fresh perspective. So Ronnie, can we ask you to ask your question by video? Thank you.
Michael, you explained the need for common tools, common methods, common approaches, and basically make everything more efficient. I would like also to propose that we look in common multi-locational sites. I'm sure because of the biology, we cannot combine all the crops in all sites, but I'm sure in some places we can combine at least 2 or 3. Now the banana program goes to one site, and 2 kilometers further, there's another crop program going to another site. I think we should I propose we make an inventory and see what can we bring together in one site. What's your take on this one?
I could not agree more, Ronnie. And I apologize that I obviously didn't do a good job of explaining my slide number 20 that I've got up in front of me at the moment, the EIB Managed Crops and Hunger Investments. This is exactly what we're planning to do. This is what I mean by the hub and spoke model, that we intend to invest in hubs that are for the benefit of multiple crops at a particular location, totally agnostic of what centre they may be coming from, but looking at what's required within the region. I agree with you that in some cases, I mean, there are going to need to be satellite locations that are very crop specific. That's just the way it is. We need to make sure that each crop is properly catered for, but there's a lot more that can be done. We can be much more strategic, I think, than what I've been in the past, and that's what we're looking to do. And the timing is right now with the move to 1CG. It's, because it enables us to do this in a way that we have found more difficult to do in the past.
Okay. Thank you very much, Ronnie, for that question. I see another question from Chidozi, but before we address that, I think we have some fresh questions. So Chidozi, if you don't mind, we will ask one of the new questioners. So this question is from Kalinga Nire. Thank you for your presentation, Michael. Multi-location trials for tree crops are not easily implemented due to the space and long-term assessments required. What are your comments on that?
Okay, I'll start by saying that tree breeding is not something that I have any expertise in. I expect that there still is G by E, and I expect that with the current technologies and methods that are available, that despite the challenges of replicating any particular genotype, that it may still be possible through test trialing of sibs or half sibs or even other related material to test across a range of environments and get predictions for more than just one environment, and to try and model that that G by E in a better way, because it's an important driver of variance, is the interaction. So that's really all I can offer. I'm sorry. Yeah, it's a challenge. Not pretending it's not.
That's on trees, yeah. An interesting question from NASA Yao. So NASA is asking, can you explain more on the mechanism of assessing genetic gain, and over how much time does genetic gain need to be estimated?
Yeah, it's a good question. I think this is mostly about looking forward than it is about looking back. So let's make a commitment here and today that looking forward from now on, we will ensure that that late stage trials in particular, but you probably want to do this for all of your trials, for all stages, particularly late stage trials, that there's sufficient checks, that the trial design is done in such a way that that an analysis could be done, that BLUPs are calculated, that there are sufficient checks, and most importantly, that there is continuity of checks across years, because checks will become outdated and you're going to want to swap them out. There has to be a strategic way of doing that so that you can have continuity of an analysis across years. And so let's make the commitment to start that from today. Yes, looking back, we can take the data that we've got already and try and do a backward-looking analysis, but we should make sure that, at least going forward, that in 5 years' time, that we've got at the minimum 5 years of very high-quality data.
Okay, thanks, Michael. A couple of comments from Harish and Rajiv, not specific questions, but some guidance on strengthening NAS partnerships through the existing CGIAR projects. So those are very well noted, and thank you for those comments, Harish and Rajiv. And I think we have time for one final question, so we'll move back to Chidozi. And again, a very good question from Chidozi. So Chidozi is asking about, the different components of the pipeline, pre-breeding, population improvement, and delivery. And I guess each of them need to be scaled, but sometimes resources are limited for each section of that pipeline. So what is the plan? That's Chidozi's question.
It's a great question, and I guess I should have expected it coming from Chidozi and his background. Thank you for the question. It's I'm not going to give hard and fast numbers, and I mean many of these questions that I've been receiving in the last 10 minutes are probably better answered by the module leads that are the respective module leads that are a better place to answer them. So, but I'll do my best. I'm not going to give any hard and fast answers. What I can say is talk conceptually that the population improvement component there is the powerhouse, is the engine behind the genetic gains. It's the engine from which products can be extracted, and so really that is where the majority of the resources in many cases should go. But as the role of any particular program moves more or less upstream or downstream, then that can have an impact as well. But just conceptually, that's where the genetic gains come from. So I would not like to be trying to extract varieties from a population improvement program that is under-resourced, because you won't be extracting things that are very good. Likewise, if you look at the front end, if you look at the parental building or pre-breeding or trait integration pipeline that might feed into the population improvement, the same thing goes. I mean, if there's a bottleneck there in that population improvement, then you can have the best parental development program bring in really high quality traits in new germplasm, but if it's not being recombined in a way that can package it up in a variety for farmers and making consistent and rapid improvement of those populations, then it won't. It'll get stuck and get caught in that bottleneck before being delivered. So I can't give hard and fast numbers, but it's important, and that's not to take anything away from the importance of parent building or trait integration, because I mean that's a critical role for CG breeders and the CG going forward. And I'm certainly not to indicate that it's not.
Okay, thanks very much, Michael. Thanks for taking those questions, and thanks to everyone on the session for your active participation and for asking these insightful questions. So with that, we would like to close that part of the session and move on to the breakout sessions. So we will now have 45 minutes of breakout sessions. There are 3 options. There is a session on genotyping, there is a session on bioinformatics, and a session on NAS engagement. So I'd like to ask everyone, please click session on the top left-hand side and then choose the breakout session that you would like to join. So thank you, everybody, and please enjoy your breakout session.